Okay, well, some of you have had some questions about the Heparin Protocol, so I'm going to see if I can help answer that, and I'm going to record it, and so you can have it as a resource wherever you like. All right, so what we have here is the Heparin Protocol. This is off of the Nursing 220-230 practice test, which you should have available to you. So I'm just going to go over some highlights for this and how to answer this question. The first thing here is you review and you see this protocol that's, I got to scan in order to get to it, and there's a lot of information. The first thing is you look at the top, it tells you the protocol: bolus the patient with heparin, 80 units kilogram body weight, and start the drip at 18 units per kilogram per hour. Patient's weight is 110 pounds, and then it goes through the protocol. Then you get down here to your questions. Answer the following questions. It says calculate the number of milliliters to administer for the bolus. So you need a couple pieces of information. So you know the bolus is 80 units per kilogram body weight, and you know that the body weight's 110 pounds. So step one, you got to convert pounds to kilograms. So you're going to do divided by 2.2, and then I think you get 55 pounds. So let me just double check that. All right, double checking. 110 divided by 2.2, and oh, I'm sorry, it's 50 pounds. So, whoops. Anyways, 50 pounds. Okay, I'm sorry, not 50 pounds, 50 kilograms. Okay, so all I did was a basic conversion of pounds to kilograms, and hopefully at this point you should know how to do that. So in order to answer question A, I need a piece of the protocol, and the piece of the protocol I need is actually in step 2, which is right here. Okay, heparin 25,000 units in 250 milliliters, half normal saline. And then it says the bolus dosage strength of 1,000 units per milliliter. Well, the first question says calculate the number of milliliters to administer for the bolus. So that's an important thing, milliliters and bolus. We already know that bolus is in units, but I need a way to convert units to milliliters, and guess what? That's what this is right here. Okay, so what I'm going to do is I'm going to take that 50 kilograms, just going to write it over here. I'm going to multiply by my 80 units per kilogram, and I'm going to also multiply by 1 milliliter per 1,000 units, because I don't want kilograms. I don't want units, I want milliliters. So I can cross these out. I can cross this out. And then I'm left with milliliters after I do my calculations. So when I do 50 times 80 divided by 1,000, I get a big number 4. And I apologize for all the steps here of holding this and writing at the same time. Anyways, 4 milliliters. So that's my answer for A, is 4 milliliters. That's how much the bolus dose of heparin would be. The next says calculate the infusion rate in milliliters per hour for the heparin IV drip. And so I need this little piece of information, the 25,000 units and 250 milliliters half normal saline. And then it also tells me that I'm going to start the drip at 18 units per kilogram per hour. So this is saying what is my IV drip in milliliters per hour. And again, I have 18 units per kilogram per hour. So again, I need to use that 50. So I'm just going to actually come down here. I'm going to do 50 units, and I'm going to do times the, where was that, 18 units per kilogram per hour, and then I'm going to multiply, I want milliliters, right, so that 250 milliliters over the 25,000 units. And you can see that written out right there. Okay, and I know I'm doing it right because I can cross out units. That was actually supposed to be kilograms. I apologize. I can cross out units. I cross out kilograms, and I'm left with milliliters per hour. Okay, so when I run that through, 50 times 18 times 250 divided by 25123 equals 9 mil per hour. And so that's my second answer. When I go up here, 9 mil per hour. Okay, pretty straightforward. And notice I haven't used anything else in this Heparin Protocol. There's a lot in here, but I haven't used everything. I've only used what I've been asked to use, which is the basic standard protocol, which is how you answer A and B. So the shortcut is convert pounds to kilograms, apply what the bolus, what the protocol states, and then go to step 2, okay? Then, if you notice, it says here, after 6 hours, the patient has an APTT of 43 seconds, calculate the number of milliliters per pair, calculate the new infusion rate. So I'm going to go to this boxed area, and I'm going to look for where does APTT of 43 seconds fall in a range, and that actually is number 12, because 43 is between 36 and 44 seconds. It tells me to rebolus with 40 units per kilogram and to increase the rate by 2 units per kilogram per hour. So let's do that. Now the first step, the initial bolus, according to protocol, was 80 units per kilogram body weight. The new bolus, we're going to rebolus them at 40 units per kilogram per body weight. So if you'd like to do a shortcut, just take, since it's exactly half, 80 and then now 40, you could just say that the answer is 2 milliliters would be the bolus. So we'll just go ahead and write that down. If you'd like to see the math, we're just going to go 50 kilograms times the 40 units per kilogram, and then times, again, we use the bolus, which was right up here. That's my bolus strength. That does not change, okay? I'm going to use 1 mil per 1,000 units. And then again, we're going to get the 2 milliliters. And you can confirm that if you like on your calculator, okay? So not too much to do there, just following the same steps. And guess what? We're going to do the exact same thing here, but it says now we're going to increase the rate by 2 units per kilogram per hour. That's important. Now, the initial rate was this 18 units per kilogram per hour. So 18 plus 2, my new infusion rate is actually going to be 20 units per kilogram per hour. So if you want to write that down somewhere, I'll just put it over here. 20 units per kilogram per hour. And I apologize for my sloppy handwriting. I'm trying to do this while holding the phone. Anyways, 20 units per kilogram per hour. So in order to calculate that, I'm just going to actually start back up here. I still incorporate my weight, 50 kilograms, times my 20 units per kilogram per hour. And I'm also still going to use this 250 ml over 25,000 units because that's the only information I have to do that. So 50 times 20 times 250 divided by 25,000. I know I set it up right because I can eliminate my stuff if you do it this way. And then I plug it into my calculator. 50 times 20 times 250 divided by 25,000, and that comes down to 10 mil per hour. So that's my final answer for that. So I hope that helps out with the Heparin Protocol. If I was going to manipulate this data, a couple things I can change. I can change what is the APTT. So if it's another time variant, if it's 78 seconds, if it's 47 seconds, if it's 30 seconds, if it's 120 seconds, you can see that there's different categories and different things to do within those time frames. And then you can also see that the other thing I can change is the patient's weight. So maybe the patient weighs 240 pounds or 300 pounds or 125 pounds, whatever the case may be. But as far as, at least for this course and this test question, I really can't change the initial bolus or the initial drip rate because that seems to be a standard. Anyways, I hope this was helpful. And if you have any additional questions, let me know.